Hello kids, in today's class we are going to move ahead in this chapter and we will learn more about algebraic expressions. So in our last class we have learned about the literals, we have learned about the variables and constants, and also we have seen that what are the algebraic expressions. So let us go through the basic algebraic expressions first. So I'm writing an expression here, 3x plus 2y. So when I talk about this expression, this whole is the algebraic expression which contains the addition operator. Okay, and here 3 and 2, they are the numeric numbers, or you can say they are the numbers, and x and y, they are the literals. Okay, and also we have studied about constants and variables. So constants are the numbers which have a definite value or their value doesn't change with time. So if I talk about this expression, we have two constants. 3 is a constant here and 2 is also a constant here. And now talking about the variables, they are the numbers whose value changes. Okay, so we have two variables here. X is one variable and another variable is y, right? And this whole together, it's a algebraic expression. Now we will learn about the next thing, which is called as terms of algebraic expressions. So I'm writing terms. So what are terms? Again, I'm taking the same example, 3x plus 2y. So in this whole algebraic expression, we have two terms. This is one term and this one is the second terms. So these terms, they are joined with the operator plus. Okay, so this is the expression which is having two terms. 3x is one term and 2y is another term. Now I'm taking another example here. I'm taking the example 2xyz. So kids, if we see here, this is also an algebraic expression. Why? Because we have 2 multiplied by x multiplied by y multiplied by z. We have multiplication operator here. Okay, but the term, we have only one term, that is 2xyz is the term here. Okay, so these terms, they are separated by the operators plus and minus. When we have to see that how many terms are there in algebraic expression, then we will not count multiplication or division. Okay, so for counting the terms, we will only consider plus and minus. So I'm going to tell you more examples so that will be much clearer to you. So now here I'm taking one example, x square plus 2y minus z. So if we see this whole expression, this is algebraic expression. And in this algebraic expression, we have x, y and z. These three are the variables and 2 is a constant. This 2 I'm talking about, this is a constant here. Okay, so also this 2, the one which is in the power, is also constant. Right, now let us see how many terms are there. So when we will see the terms, we will see the operators plus and minus, and we will see that how many terms are there which are then separated by these operators. So first term we have here is x square, then we have 2y, and the third one we have z. So in this whole expression, we have three terms. Okay, so I hope you have understood now what is a term. Terms are separated by the operators plus and minus, that is addition or the subtraction operator, in any algebraic expression. Okay, so a combination of constants and variables which are connected by any one of the symbols plus, minus, multiplication or division is called algebraic expression. Like we have seen 3x plus 2y, 2xyz and this. All these three are algebraic expression. And now the several parts of the expressions which are separated by plus or minus, they are called terms of the expression. So whenever we have to see how many terms are there, then we will have to see only these operators and then so that we can identify how many terms they are separated in this expression by these operators. Okay, so this is how we can see that. Moving ahead in this, we have something called as monomials. Then we have binomials. Next we have trinomials. Also we have quadrinomials. And the last we have multinomials. Multinomials. Okay, so now to understand that what is a monomial, whenever we have any algebraic expression which contains only one term, they are called as monomials. Example I'm taking here is 3x is one example, 2y square is another example, 6xyz square another example, 3abc another example. So if you see here, in all of these examples we have only one term. In this is a complete algebraic expression, right? Because it has a constant x and it has a variable 3. So this is a complete algebraic expression, but in this algebraic expression we have only one term because we do not have any addition or a subtraction operator which is then dividing the different terms. So we have only one term here. Similarly, if we see here, we have 6yz square. This complete is one algebraic expression. But again, here we have only one term because we do not have any plus or minus operator here. Same with 2y square and same with 3abc also. Okay, so monomials are the algebraic expressions which have only one term. Okay, now coming to binomial, as the name say bi, it has two terms. So this algebraic expression, it contains two terms. So example, I'm taking 6x plus y. This is one term, 6x. This is another term, y, and they are separated by a additions operator. Okay, next one I have 3x square y minus, let's say, 5y z. So in this one also, this is one complete term, this is another term, and both the terms, they are separated by subtraction operator. Okay, so this is example of binomial where we have two terms, they are separated by subtraction operator. Okay, next we have trinomials. Here we have three terms. Okay, so simplest example is x plus y minus z. We have here we have three literals or three terms. You can say we have three terms x, y, and z, which are separated by the operators plus and minus. Right? Another example I can take here is, let's say, 2y square plus 6xyz minus 21. Okay, this one is also a trinomial because we have three terms which are separated by the operators, right? Last one is the quadrinomial. So in quadrinomials, we have four terms which are separated by these operators. Example I'm taking here is x square minus y square plus z square plus 6. Okay, so here we have four terms, x square, y square, z square, and 6, and they are separated by the operators. Easy. Last one is multinomial. So multinomial are the algebraic expressions where we have more than one term. More than one term. So if we have two term also, that means your binomial, trinomial, and quadrinomial, three of these, they come under the multinomials. Okay, but monomial, it doesn't come under the multi. So multi itself says that it is more than one. So if in the algebraic expression we have more than one term, we call it as multinomials. Okay, so I hope kids you have understood that how in algebraic expression we have different terms. What is a term? How when the terms they are separated with plus and minus in the when we have plus and minus separators in the algebraic expressions, then we get the terms. They are always separated by these two operators only, plus and minus, right? And then the monomial, which has one term, binomial has two, trinomial has three, quadrinomial has four, and multinomial has more than one term. Okay, so this is done. Now, next concept in algebraic expression is factors. So, like in the case of numbers, we have done factors. Similarly, in the case of these algebraic expression also, we have the factors. Let us see what are the factors here. So, example. First of all, I am taking the normal numbers. I'm taking a number 15 here. So when I say 15, what are the factors of 15? 5 is one factor of 15, 3 is another factor of 15. That means if I multiply this 5 and 3, I will get 15, right? Similarly, in the case of the algebraic expressions, when we have numbers and literals, they are multiplied with each other and we get any product, we have number factors like this and we also have the literal factors. Example. Example, I'm taking 6xy. If I'm taking 6xy here, then the factors will be 6, x and y. Because if I multiply these three, I will get this. Okay. So 6, x and y, these three are the factors of this algebraic expression 6xy, where 6 is a number factor, but x and y are the literal factors. Okay, so we have number factors and we have literal factors here, 6xy. Another example I'm taking here is 8x, y square and z. So here we have 8, x, y and z. These four are the factors of this given expression where 8 is a number factor, x, y, z are the literal factors. Now consider the case where I have 21, let's say I have 21ab. So what are the factors now? In this case, my factors will be minus 21, A and B, where this is a number, and these two are the literal factors. Okay, so this is how we can see this. Supposedly, I have factor something like minus x squared y squared. Now, what will be the factors? See, these literals, they do not exist in negative form, but our numbers do exist. So, we have minus 1, x and y. These three are the factors, where minus 1 are the number factors and x and y, they are the literal factors. Okay, so this is the concept of factors. Now we have another coefficient concept here. And what are these coefficients? These are basically the numbers and the literals which when multiplied they give us the factors, the other factor. Example, I am taking example this one, 6xy again. I have 6xy. Okay, in this 6xy, we have 6x and y are the factors. These were our factors here. Now, if I want to say that what are the coefficient of 6? So, the coefficient of x will be xy, because when these two are multiplied with 6, then we will get the product or we will get the main number or expression. Okay, so the coefficient of 6 will be x and y. The coefficient of y will be 6 and x. Similarly, the coefficient of x will be 6 and y. Okay, so we can say that in a product of numbers and literals, any of the factor is called the coefficient of the product of the other factors, like what we have seen here. Example, they are saying in 5xy, the coefficient of y is 5x and the coefficient of x is 5y, which we just saw. In minus 7xy square, the coefficient of x will be minus 7y square, that is the remaining ones, and the coefficient of y square will be minus 7x, the remaining part. And if we have only minus 6, then the coefficient will be minus 1, like how we have seen here. Okay, so this is the concept of coefficients. Now the constant terms, so constant and variables, kids, we know. Now in our expression, again they have given us some examples, although we have identified it, but let's do it once more. So if we have 3x plus 6 here, so in this case the constant term is 6, because 3 is getting multiplied with this and this term will be changed. Also, if I have another expression, x square plus y square minus 2 by 3, so in this scenario the constant term will be minus 2 by 3 here. Okay, so these are the numbers whose value doesn't change, it remains static. Now let me just erase it, and then we are going to learn about the another concept called as the like terms and unlike terms, which are very important to solve the further problems. Okay, so like terms are one whose literals are same. Okay, and unlike terms are the one whose literals are different. Okay, they have got same, whose literals are same, whose literals are different, or you can say whose literal factors are same and whose literal factors are different. Example of like we are going to take first here. Okay, so supposedly I'm taking the example 6x square minus 21x square 700x square. So these three are the terms. So in these three terms, our literal factors are same. Here we have x square, here we have x square, and here also we have x square. So since the literal factors are same, these are called like terms. Now let's say I am adding one more literal to it. I am adding 5x cube. So when I am adding in the sequence 5x cube, this will be unlike term. Why? Because now the literal factors are different. We have x cube here, but in the other terms we had x square. Okay, so that means like terms are the one whose literal factors are same. Another example, kids, I'm taking here is minus 75 xyz 612 x square yz 414 x square yz 313 x square yz. So when we see all these in all the terms here, we have x, y, z, but the factors are different. In the first term, 313, if I'm writing 313 x square yz, the factors are x square yz. In the second term, we have only x, y, z. We do not have x square, so that means these two are different, right? In the third one also, we have x square z, which is same. And in the last one also, we have x square z, which is again same of this. So that means 313 x square yz, 612 x square yz, and 414 x square yz. These three are the like terms, whereas minus 75 xyz is unlike term because the factors are not same. Okay, so this is how we have to check whether the given terms are like or not. They should have same literal factors to be like. Okay, so now kids, we have another thing where now we have to put the values of the given constants in the expression and find out the complete value. Okay, so what I mean to say here is the example one. I'm writing same here. We are given x is equal to 1, y is equal to minus 2, and z is equal to 3. So using these values of x, y, z, we have to find the value of the given expression x cube plus y cube plus z cube minus 3xyz. So this is the expression given to us, and what we have to do is we just have to simply substitute the value of x, y and z in the given expression and find out the value. So let's do this. So kids, whenever we have this kind of questions in the examination, first of all you have to write whatever is given to us, the expression, and then you have to write, put x is 1, y is minus 2 and z is equal to 3. This step is important because now you are telling you are going to put these values. And the third step will be you have to put these values and write the expression as is. So I'm taking x as 1, this is 1 cube. I am taking bracket here, and it is always advisable to put these things in brackets when you have multiple values. Okay, it will be easy to solve. So 1 cube, then this plus comes, and then y cube. Y is minus 2. So minus 2 cube. Then z cube plus z. Z is 3. So this becomes 3 cube. Now this minus comes, minus 3 x, y, z. X is 1, y is minus 2 and z is 3. This is the expression after putting the values. So now let's solve. 1 cube is 1 only. So this is done, plus 2 cube. Minus 2 multiply by minus 2 multiply by minus 2. So if we multiply minus 2 3 times, it will become 8, minus 8. Because minus into minus, see, it will be something like this. How we have to solve this? This is minus 2 multiplied with minus 2 multiplied with minus 2. So this is 2 into 2 into 2 is 8, minus into minus plus, and then this plus into this minus will become minus here. We have done this in chapter integers, right? So we will get minus 8 here. I am writing minus 8 here. Then 3 cube. So 3 cube will be 3 into 3 into 3. That is 27, right? So 27 here. Straight away this will be in plus. And now let us do this. I'm keeping this minus here, and now I'm putting a bracket and multiplying this. We have 3 into 1, which becomes 3, and then into minus 2. Minus 6 and into 3, minus 6 into 3 is minus 18. So that is what I have done. I have multiplied 3 with minus 2 with 3. So when we are doing this, we will get 3 into 3 is 9, into 2 is 18, plus into minus will become minus, right? So here I am getting minus 18. Okay, now let's solve it further. So this is 1 plus into minus. Why into? Because we do not have any number here. So this is in multiplication, right? So we do not have any operator. Plus into minus is minus. 1 minus 8. This is as is plus 27. Minus into minus will become plus. Okay, so we have this expression. So now let's solve it. We have all plus here, 27 plus 18 plus this one. So when we are going to multiply this, this will become 28 plus 18. So 28 plus 18 is 8 plus 8, 16 and 46. 2 plus 1, 3 and 1 more, that is 4, 46. This is plus 46, and now this is minus 8. 46 minus 8 will be 38. So our answer will be 38 here. Okay, so this is how we have to do such questions. Just put the values, solve them, and always use the brackets while solving them. And if at all you think that you're not able to solve this, please go to the chapter integers, where I have told all the formulas and we have already done them. Revise it and then start solving this chapter. Okay, so this is one example. So similarly kids, we have another example here where we have 3x y raised to the power of 4 minus 15 x square y plus 4z. So here also we have to do the same thing. We just have to substitute the given values of x, y and z and solve this expression. Okay, so I'm also doing this one more example here. Question number 2. So what we have to do, first of all, write down the expression which is given to us, minus 15x square y plus 4z. So kids, since we have multiple literals here, it is always advisable that whenever you write it, cross check it again that you have written the correct values or not. Okay, and now think, the second step is put x as 1, y as minus 2, and z is 3. Okay, so let's do it. So we have 3, and then in x we have 1, and in y we have minus 2 raised to the power 4. This is first expression. Then we have minus here, 15x square, that is 1 square, and y, that is minus 2. Second expression, then this 4 here, and then z 3. Okay, so this is one, this is you can do it like this, and you can put a big bracket over there outside. So let's solve this. We have 3 into 1 3, and then here we have minus 2 raised to the power 4. So minus 2 raised to the power 4, again I am telling here this is 4 times minus 2 multiplied together. So this will give us 16, and this is minus into minus plus, plus into minus minus, and minus into minus again plus. So we will get 16 here. So we have 3 into 16 here. Come here, here we have, since we have minus outside, I am putting a bracket over here. Okay, so 15 into 1 square, 1 square is 1 only, so 15 into 1 is 15, multiplied with minus 2 is minus 30. So this is minus 30, and this is straight away 4 into 3 is 12, 6 into 3 is 18, minus into minus is plus 30, this is plus 12 only, so we have all the terms in positive, we can add them directly. So 18 plus 12, we will get 30, 30 plus 30, we will get 60. So our answer is 60 here. Okay, so likewise you have to practice more questions on this. Another thing which we have here is second question, which says that identify the monomials, binomial and trinomial from the following expression. So question number 2, example number 2 rather, first part is 3 minus 3x, y and z, and what we have to find, that is it a monomial, binomial or trinomial. So in this case we have only one term, so this is a monomial. I'm doing it here. If you see here in the second one, we have two operators, plus and minus, separating these three terms. So this is trinomial. I'm writing T here, I'm writing for monomial M. Third one, we have only minus 7, monomial. In the next one, fourth, we have x square plus y square plus z square minus p. So we have 1, 2, 3, 4 terms separated by these operators. So this is a quadrinomial. So I'm writing Q here. Next one, we have x plus 5. We have two terms. So this is binomial. In the last one, we have 6a cube b. So we do not have any plus or minus operator. Only one term is there. So this one is again monomial. Okay. Coming to next question, where we have to write down the coefficient of x in 9xy. So the coefficient of of x in 9xy will be 9 by straight away. Of a in minus 7abc will be leave a and rest all the terms, minus 7bc. Of xyz in minus xyz will be minus 1, and of b in minus abc will be minus ac. Okay, so leaving that term, all the other terms will be the coefficients. Okay, so class, I hope you have understood all this. Please go through this again, and we will do the exercise in our next class. So I will see you all in the next class now. Thank you.